So for this video, we're going to kind of put all of the pieces together, okay? And talk about how to graph a rational function kind of from top to bottom. Now, the book's going to talk about like a 7-step method or a 5-step method, something like that of graphing one. Now, first off, my order that I do stuff is different than the book's order. Personally, I like to find all the stuff that I've got to kind of stay away from. So all my asymptotes and stuff like that, I like to find all that first. And then I'll find my y-intercept by plugging in 0. I'm going to find my x-intercepts by setting the numerator equal to 0 and solving that. And then based on how many asymptotes I've got and how many different kind of chunks of graph that creates, I need to have at least 1 point in every chunk in order to kind of figure out my shape. And then I've got symmetry down lower, because similar to when we talked about graphing polynomials, a lot of times I can decide whether or not I have symmetry based on where my asymptotes are and stuff like that before, without actually having to plug it in and determine that type of stuff. So the equation that we're going to look at graphing, okay, is going to be 3x minus 3 over x minus 2. Okay, so this is the equation that we're going to look at. And so we're going to kind of run the top to bottom ordering of stuff. So first thing is I'm going to handle my domain. So I'm going to do x minus 2 can't be 0. I'm going to add 2. So x can't be 2, which means my vertical asymptote, again, sometimes abbreviated VA, is going to be an x equals 2. So I'm going to kind of get a grid space going up here, and we'll get some lines going. So now I have a vertical asymptote at 2. So I'm going to go ahead and dash that in. Okay, so there we go. Now, for my horizontal asymptote, we're looking at the biggest power on the top. So I've got a plain x, so the biggest power on the top is 1. The biggest power on the bottom is also an x, so that's 1. They match, so that is Ratco. So we're going to go up to those coefficients. So it's right up here in the front. So it's going to be 3 over 1, which is 3. So I'm going to have a horizontal asymptote at 3. So we'll go ahead and dash that in. Okay. So next thing is I want to get my y-intercept. And for that, we're going to plug in 0. So I'm going to do 3 times 0 minus 3 over 0 minus 2. It's going to give me negative 3 over negative 2, which is positive 3/2. So up here on my grid space, on my y-axis at 3/2, which is 1.5, I'm going to put a dot right there. For x-intercepts, which was the next thing, we set the top to 0. Okay, so I'm going to add 3, divide. So my x-intercept is at 1, so I'm going to put a dot there. Now, knowing kind of the shapes that we saw before, and some of those basic ones, this feels very much like I'm going to stay off the lines, okay, and kind of cut through here. Okay, so I can go ahead and play connect those dots and graph. Now, I do know that I'm not going to have any symmetry, because if this was going to fold in half and be even, okay, so it folds in half on the y-axis, I would need to have another vertical asymptote sitting right over here at -2. I don't have that, okay? The other thing is, if this was going to have origin symmetry, then I would also need to have one over here at -2 for a vertical, because it would rotate around. But I would have also had a or an x-intercept that was here at 1. There would be another one over here at -1. So I don't have any symmetry. Now, I do need another. I need to know what's going on over here on this side. I don't know. Okay. So I'm going to pick any number that I want that's on this side of that vertical asymptote. So I'm going to pick 3. Okay. So I'm going to plug in 3. So I've got 3 times 3 minus 3 over 3 minus 2. Okay. So 3 times 3 is 9, minus 3 is 6. 3 minus 2 is 1. So that's just 6. So I'm going to come back up here. So 1, 2, 3, 4, 5, 6. So I have this dot up here. Again, kind of knowing my shapes, this is now going to graph this way. Okay. So we've got kind of this angle here and that one up there. So that is what our process would look like for graphing these shapes. Okay. Now, one thing that I do want to mention, okay, I'm going to flip over to where I've got a bit of a grid board here. Okay. One of the things that I do want to note is that if you were to have, let's say, a couple of asymptotes, vertical asymptotes, okay? So I'm going to put in a couple of them here randomly. Okay, and we'll put in a horizontal one here. Okay, now, what I want you to be aware of is generally out here on the outside edges, you're going to get graph shapes that kind of follow the rules and they, stay off their lines. They do stuff like this. Could be up here in this one or down here. Now, in this middle section, you could get graphs that do like this, that are parabolic in shape. But the other thing that can sometimes happen in this middle chunk is we sometimes get these kind of little S-curvy ones like this, okay? And I want to make sure that you're aware that this crosses over the horizontal asymptote, and that's okay. When we talk about horizontal asymptotes, it's more what they do at the outside edges and how they taper tail. Sometimes you get these little singleton crossover points. This is a scenario that if I had double asymptotes going on like this, or I had more than a couple vertical ones, I would want to have at least 3 points in this middle chunk so that I knew that that was S-curved and not a parabola shape, okay, as that was processing through. So I just wanted you to be aware that sometimes we do get graph shapes that look like that. Other times, though, it will just be a parabola shape through there.